Okay, so today we're going to talk about quadratic functions. Now, you've worked with quadratic functions before, but maybe they weren't called that. The graph of a quadratic equation is a parabola, and a lot of people just think parabola functions. Okay? Remember that parabolas are kind of like a U shape, looks like that. It's facing down, or it could go up. We don't have them going left or right because that's something else. We have two forms for quadratic, that should be functions. Sorry about that. Okay. Standard form is when we have f of x is equal to ax squared plus bx plus c, which if you remember the quadratic formula, we had to have our equations in standard form, ax squared plus bx plus c, to be able to plug into the quadratic formula. Same thing here. And then we have what's called vertex form. That's when we have f of x is equal to a times parentheses x minus h quantity squared plus k. Now, the way to tell the difference between these two, standard form has no parentheses. And our vertex form has parentheses. Or some of my students say, yes, parentheses. You need to be able to tell which format you have. Okay? So A, remember A is that leading coefficient. But what A does to the graph, if A is greater than 0, which is a fancy way of saying A is positive, then the parabola opens up. Okay? If A is less than 0, which means that A is negative, then the parabola opens down. Oh, should write down first before drawing it. Here we go. Now the way to remember this is if you're positive, you're happy, and you smile, the corners of your mouth go up. If A is negative, so if you're negative, you're angry, you're frowning, and the corners of your mouth go down, down like a frown. And the behavior of A is going to adjust or affect our vertex. Our vertex of the parabola is located at the point H, comma, K. If you want to find the vertex from standard form, H is equal to negative B all over 2A. So like the quadratic formula, but you erase that plus or minus square root. And K is equal to F of negative B all over 2A. I know that looks scary, but we'll get into some examples and it won't be so bad. You may be wondering why I'm only talking about standard form to find the vertex, because vertex form, you can see that the H and the K are already there. It's in standard form, we have to do a little bit more work. Yeah. All right, so if A is greater than 0, which means that the parabola opens up, the parabola opening up, the vertex is the minimum point on the graph, and K is the minimum value of the function. Okay, so keep in mind that your vertex is like your turning point. So if we're opening up, our vertex is the point all the way down here. That's HK. And he's at the very bottom, which is why he's a minimum. However, if A is less than 0, so we're negative, which means the parabola opens down, then the vertex is the maximum point on the graph, and K is the maximum value of the function. And if we look at a drawing of that, my graph would be going down. HK is our turning point. So vertex is turning point. And here it's at the very top. And that's why it's a maximum. Now, with our axis of symmetry, we have a vertical line in the form x equals to h that divides the parabola in half and acts as a mirror for the ordered pairs. So if I were to look at a parabola opening up, and we have my vertex HK, my axis of symmetry is going to be this vertical line that goes through the vertex at x equal to h. And what I mean by it being a mirror is that if I were to fold the parabola on this axis of symmetry, on this dotted line, it would overlap on itself because this point on the left is the same distance away from the axis of symmetry as that point on the right. The same thing happens if my graph were to open down. So if it's opening down, I still have my vertex of HK. Then my axis of symmetry would be the dashed vertical line, splitting the parabola in half if I would have drawn it correctly. And then the ordered pairs would be the same on either side. I know that's a wonky drawing, but can kind of understand what I'm going for. Let's get into some examples.